3, 2, 1. Alright, hello everybody, this is how we play the Cocoa Collision simulation. So here's our game board, and the important thing to notice about this game board is that it has 4 columns. So for both the cocoa molecules and the air molecules, you want them in 4 columns. There's more air molecules than there are cocoa molecules, but that's okay as long as you have them in 4 columns. This simulation will work fine. Now, everything that happens in this simulation happens where the cocoa molecules meet the air molecules, and we call this the collision zone. Now, you can use this game board if you think it's going to help you out, or you can leave it aside. And we're going to set it aside right now just so that everything's a little bit easier to see. Now, we have our cocoa molecules, and you can cut these out. And just so you can see them on the video, we made a little bit bigger versions. So each molecule tells you what it is, whether it's a cocoa or an air molecule, as well as how much kinetic energy it has. The bigger this number is, the more kinetic energy. So this particular molecule is a cocoa molecule, and it has 10 kinetic energies. And what we want to do with these molecules is for both the air and the cocoa, it's very important that we shuffle them and mix them up. And the most important parts of this game is that you shuffle well and that you lay out your molecules in the same way every time and without cheating. You're not in control of where these molecules go. Remember, molecules fly around just randomly, without a plan, without any sort of thinking at all. So we want to make sure these molecules get laid out in the same sort of way. So the way I like to do it is we put our molecules in a pile, and I just pull from the top of the pile and put them in my 4 columns. And each round you play, you're going to want to do this in exactly the same way, and that'll help you do it randomly. Remember, you don't have control over where these molecules go. They have a mind of their own. Alright, so now Lindsay and I have our molecules laid out. We're ready to start our first round. So to help you see this, we're going to move these little cards out of the way. You won't do this. This is just so you can see on the video, and we're going to do this first round with some bigger, easier to read cards. Alright, so we're ready to start our first round, and this is our collision zone. This is where the cocoa molecules meet the air molecules. And for our first collision, we push the molecules forward, and alright, and what we want to do is we want to add the kinetic energies up. So I'm bringing 10 pieces of kinetic energy, and so I want to add 10 of my little kinetic energy beans. So that's 2, 4, 6, 8, 10. Alright, and we put them together in the pile, and then we equally split them up. So if I take this side, Lindsay can take that side, and now I have 6 kinetic energy. So I want to keep track of that. So we'll write this on our cards. And on the molecules you'll be using, there's a space for you to write in this new amount of kinetic energy. The other thing we want to do is we want to keep track of how the kinetic energy changed. So I went from 10 to 6. That means I lost 4. And I want to record that on my data sheet. Now your data sheet should look like this. And what we did is we just rewrote it a little bit bigger so that you could see it on the video. So our first collision, I had a -4. What did you have, Lindsay?
+4.
Alright. Okay, and now we're ready for our second collision. All right, so we push them together. Let's see, I'm bringing 7. Lindsay only has 2. All right, and now you might notice that there's a problem here. We can't split these piles equally because it's an odd number. So our rule is whoever was going slower gets to take the first piece. So let's see, Lindsay had less kinetic energy than I did. So go ahead and take the first piece. And now we can split this equally. All right, so I have 4. So I want to write that on my card.
And I had 5.
All right, and let's see, how did this change? I started with 7, now I have 4. That means I lost 3. So I'm going to record that on my data table.
And I gained 3.
All right, on to the third collision. So we have, I'm bringing 8, Lindsay has 1, and we can use our collision beans if we want, or we can just kind of talk out the math as well. So 8 plus 1 is 9. That's an odd number. So Lindsay, you get to take the first one. That would leave us with 8. 8 divided by 2 is 4. So I end up with 4. And Lindsay, you have 4
plus 1.
Plus the one you got to take.
So I get 5.
And let's see, I started with 8, now I have 4. That's another minus 4 for me. What about you, Lindsay?
And I started with 1, and now I have 5, so I gained 4.
All right, let's try that again with our last one. We have, I'm bringing 12, plus 3 is 15. That's odd again, so Lindsay gets to take 1. That leaves us with 14. 14 divided by 2 is 7. And Lindsay has 7 plus 1.
So I get 8.
And let's see, the difference is 12 minus 7. That was a minus 5 for me.
And I gained 5.
Okay, so now that brings us to the end of the round. And we want to keep track of how much thermal energy we gained or lost. So we want to look at the total kinetic energy. And this will be of the cocoa, and Lindsay has the air right here. So I started with 117. And for each collision, we could add up all 12 cocoa molecules and figure out what it was, or we can just add or subtract this lost gain. So we have 117 minus 4, that's 113. We have 113 minus 3, that's 110. 110 minus 4, that's 106. 106 minus 5, that's 101. Now, the other thing we want to figure out is our temperature. And you could do the temperature for each round as well, but really we just want to know what the temperature is at the end of the round. That's the most important number. So what we do is we take our total kinetic energy and we divide it by the number of molecules that we have, and that formula is on your data sheet. So for me, I have 12 molecules, so I have 101 divided by 12, and that equals 8.4 degrees. All right, how about you, Lindsay? What do you have for total kinetic energy and temperature?
So I started with 55 kinetic energy. So I add 4, so that's 59. And add 3, that's 62. And add 4, that's 66. And add 5, that's 71. And I had more air molecules to start. So I have 20 air molecules. So I would divide my total kinetic energy by 20. And that gives me 3.6.
All right, and let's see, if we look at how our temperature has changed, I started at 9.75, and I went down to 8.4. What happened to yours, Lindsay?
So my temperature started at 2.75 and it increased to 3.6 degrees.
All right, and that's the end of this round, and so now we're ready to start our next round. And to start the next round, what we want to do is we want to take our molecules and we want to shuffle them up again. And the shuffling is really the most important part of this simulation. So you want to do a really good job shuffling, and then we put them in our pile, and taking from the top, we lay them out in our 4 columns. And now we're ready to start round 2. Now you should simulate as many rounds as you have time for. You really want to do probably at least 4 rounds, maybe 5 if you can. And if you follow these instructions, you should be all set to run this simulation. So that is the end of these instructions.